Hello, welcome back. Now we are going to look at a series of problems in backtracking one by one, and we are going to discuss how to solve each one of them. So first, let's look at the first question, which is rat in a maze. So the question is like this. There is a rat which is currently there in the place where the source is, and it has to come down to the destination, right? So wherever it is saying as the goal in the bottom right, that's the destination of the goal it has to reach. And you can see the path here, but actually the input to this particular question is going to be a matrix. It's going to be a 2 by 2 matrix which will have zeros and ones. 1 represents a wall, 0 represents a normal tile. So whatever you see as white here would be zeros, and whatever you see as dark green would be 1, right? So a rat cannot go into the wall. Rat can only walk in the space that is given here. So the output expected is wherever you see a 1, output is a 2D matrix, right? Again, so wherever you see a the path, right, the green line, in those areas it should say 1, and the other areas it should say 0, right? So the output will something look like this, right? First row will be like 1 0 0 0 0. Second row will be 1 1 1 1 0. Third row will be 0 0 0 1 0. Fourth row will be 0 0 0 1 1. Fifth row will be 0 0 0 0 1. So that's the path from the source to destination. This is called the solution matrix, or the output that needs to be printed. And it is not just for this matrix. The question is for any such matrix in any dimension, right? N by n. The solution should be working fine. So this is the expectation of the question. So now we will see how to solve this question using backtracking. We will also look at the template that we talked about earlier, right? The template for backtracking is like this. So this is the standard template for a backtracking solution. We'll talk about it in greater detail with a detailed code as well. But as of now, the backtracking code, as we already know, is a recursive code. So first we will check for the goal. Goal here is, have I reached the bottom right corner, right? Is my current position the bottom right corner? If so, you can say, hey, yeah, we have reached here, and you can return true. Second is, we'll check for invalid positions. We'll talk about it when I talk about the code. Third is this an already visited cell that I'm visiting now? Fourth is there a pruning required? And remaining things you see here, right? Don't worry too much about this now. What we'll do is, this is what is the entire template for backtracking. Now we are going to look at each part of it step by step using multiple questions. In the first question, you might be seeing some part, or 80% of this template you will see in the first question itself. Slowly in upcoming questions, you will understand the different aspects of backtracking. So let's start with the solution first. So this is the code, the actual solution code. We will discuss this code. I'll explain this code, and then moving forward, every other line of code you'll be able to easily understand. Now, this is in Java. I wrote it in Java so that for C and C++ programmers also it will be easy. For Python, it is no different. I think usually you should be able to figure out the Python code. So this n is the size of the matrix, which is 5 by 5 matrix now. Maze, this will be initialized based on the input given by the user. And this is the solution matrix where the final solution is going to get stored. So in main, it is very simple code. All we do is we initialize the variables from the user. We initialize the solution matrix. We initialize the input given by the user. And this is where the zeros and ones and the matrix is read. And once that is done, this is the backtracking code. This is the main function that we will be reviewing, the find solution. Initially, we are saying we are starting at 0, 0. X coordinate is 0, Y coordinate 0 is the matrix. That is the starting position in the matrix. And there is a solution matrix which has to be passed where the solution is going to get updated. And finally, if that function returns a true, we are going to print the solution. Otherwise, we'll say that there is no path exists, right? So the print solution function, again, we'll look at that quickly. So this is just going to print the solution matrix, which will display the final path, right? So these three, I think we have proceeded quickly. I think all of you have understood. Now we are looking at this main code. This is the most important one. Now, if you recall the template that we had seen earlier, right? We had a check for the goal. Then we had check for invalid. And after that, we had two other things which we will not discuss now, right? Whether we have visited the path already, or we have also checked for whether we have to do the pruning, right? Those two are not applicable for this question, so we are ignoring it. We'll come to that at a later question. As of now, we are checking for goal. We are checking whether it's a valid move or not. Then we set the solution matrix to 1 and we are recursively calling this function, right? We can move down and we can move right. Both the calls are made here. I'll explain each of these in greater detail below. And then if the solution is not found in either of these moves, then we said this particular position is not part of the solution and we will say that solution is x comma y is 0. Right? So now let's look at it in greater detail. So this is the backtracking solution, right? So I'll just revise you the template that we saw earlier. So this is the template I had mentioned for backtracking. This is going to be common for all the questions, right? In this, check for goal is the first one. Second is check if it is valid or not, that move is valid or not. We are not using this already listed cell and we are also not using the pruning required. These two are not used in this particular question. Then after we have done the check for the goal and check for invalid, we are saying for this particular x and y position, that is initially it is 0, 0, right? Is this 0, 0? We'll assume that is part of the solution matrix. That is the path exists in that particular part, right? And we recursively call whatever is required. In our particular case, we'll go down and we'll go right. And then if at all we are not able to find the solution, we'll say that that particular position is not part of the solution. So we'll say in the final solution, it is going to be 0. But if at all we find that through that path, we are able to get to the final destination, if we recursively call and we get to the destination, we'll be returning true. So that particular solution will be, solution is 1 will be part of the final solution, right? And this exclude also we are not having in this current particular code that we discussed, right? So this is the template. And this template is very important for you to understand. And let's go back to the code again. Now, if you look at the code actually merges with the template. So the check for goal is the first one. So what is meant by check for goal, right? There is a x and y position. We are initially starting with 0, 0. And as it progresses, the rat moves to a new position, right? So that current position, if that is the goal and maze of the destination, right, is 0. Then we will say, yes, we have found the solution, right? So we'll set the solution for that particular position to 1 and we will return true. Return true, whenever find solution returns true, it means that we have reached the goal, right? That is it, done. We don't have to any further process the backtracking. We have reached the final destination. So if at all this condition is true, then it means that we are done with it and we are returning saying that we have reached the goal. So if the goal is not the case, right? Currently we have reached a particular position which is not the goal. We'll check if it is a valid position or not. Have we gone below, right, the x-axis? I mean, x is less than 0 or y is less than 0 or x is greater than or equal to n or y is greater than or equal to n. Or is there a wall in that particular position because of which I cannot move there, right? If any of that, right, I've reached a place but that place is invalid. That means that particular cell is invalid means you will return false, right? That means you are not in the right position. So we are returning false. Again, just remember you get into a position, in that position you check all these things, right? You are not checking before you get to a place. You're saying I've reached a particular place. Is that a valid place? That's the first check that is happening. So once you find that it is not the goal and it is a valid position, then we assume that this is part of the final solution. This is what is the solution of x comma y, right? So we'll set in the solution matrix as 1 and then we call that function recursively if find solution and we are saying x plus 1. That means the next row, same column. That is, it is going down, right? And we are passing the solution matrix again, right? So if it finds a path in that, then it returns true. If by going down, right, so you don't have a solution, you have gone down and you do not have a solution means then you try right side. So every position, wherever it reaches, it's going to go down and check and it is also going to go right and check. If by going down it has reached the destination, it will not go right. But if it has gone down and it has not found the solution, then it will find the right. If both the sides it has tried, say it has gone to the next row and it has also gone to the right from the same position and it has gone further down, right? Because it's a recursive call, it is subsequently going to call the further cells. If it has gone through the entire path and from this particular x and y, there is no solution means you remove that particular thing from the path. You are saying that this x and y is not part of the final path, right? That's what is the final thing. So now let's run this particular code. Let's see what happens. So this is the input matrix that we have. The same thing that we saw earlier. if you recall the input matrix here, the same thing is what is represented in the code without the green line, right? That matrix that you see here with the walls and the free white spaces where the rat can move, this is what is given in the initial one. So you see here 5 is the square matrix, so 5 is the input n, and this is the matrix. So the zeros are the places where the tiles are available, 1 is the place where it is not available. This is the input given to the code, and the recursive code gets called, right? At the end of the day, this is the path or the solution matrix. Finally, we are displaying the solution matrix in the print solution code, right? So if there is a valid path available, it is going to find the path. Now, if you look at it, it is saying the path is here. Here is the path for it. And this is the same thing you saw in the yellow line earlier, right? This is what has found. Now, let's do some changes to see if the code is working fine. I'll block the path here, right? So I'll block it so that you cannot come to this particular position. Now, if you look at it with the zeros, you cannot go anywhere, right? We have blocked the path. Let's run it now. You see that there is no path exists, right? So this is the second level of validation for you to see how this code works. Now let's understand why we are sending the solution matrix, right? Why is it not a global variable? Why we have to send it every time, right? That is something to understand. Also to understand how we started only with 0, 0. How did it move across the entire matrix? Let's see that particular part in the next step. Now let's look at this code, right? So we have the rat in this particular case. So it is in the top right. It's a slightly different matrix than what we saw earlier, right? But what is the code that we have is, we'll go down first, that is x plus 1. Find solution of x plus 1 will be first done, and then x comma y plus 1 will be done second, right? That means you will go down and try to exhaust it first, and then going right will be the second part from every portion. So first we are in this first place. So it is in the top right where x is 0 and y is 0. And then you are calling find solution of x plus 1 comma y. That means x is going to get increased to 1 and y is 0, which means the rat has moved 1 position down, right? So from this again it is going to try x plus 1, right? It is a recursive call. So it is going to again call 2, 0, right? So it will come here. It will go to 3, 0, it will go to 4, 0, right? Till now there is no challenge. It will also go to 5, 0, but 5, 0 is outside the matrix. This is where it is going to check if it is a valid position or not, and it will find that it is an invalid position. So it will go back to that 4, 0, which is the backtracking part, and then it will go to the right side, right? So right side is again wall. So if you look at it, 5, 0 is invalid. So it backtracked, it went to the previous position, and it went to 4, 1, which is this position that I am pointing now. So in 4, 1, right, wherever the rat is currently is again an invalid position, right, because there is a wall. So it will come out of it saying that there is a wall there. So it will go to the previous position again, backtrack, and it will go to the right side, which is where it is here. From there, again it will backtrack saying that, hey, there was no path here. It will go one more step ahead. So it will come here, right? It has backtracked and it has come to this particular place. Now if you look at it, it has gone down all the way and it has backtracked and come here. So now it will try the right side. So it will move to the right. Okay. So this is giving you the idea. So it will follow all the way and then it will get to the final solution, right? But this is to give you an idea how this entire thing is working, how the backtracking is working. Now let's look at a visualization of the code that will help you understand this even further, where we will use the recursive calls and I'll show you how it works. So now I am on Python tutor. I just changed the matrix to be a little smaller one so it's easier to understand. So if you look at the maze, I made it a 3 by 3 matrix, right? So this is easier to explain the backtracking code. So it starts here, it comes down, it will come down and it will come down out of the matrix. It will say that it's an invalid position. So it will backtrack, it will go to the right, it will say that this is an invalid position. So it will backtrack and then it will go to the right, it will go to the right and it will find the solution, right? So let's see this in action. I'll show you step by step. 5 by 5 would have taken a very long time, but this will be easier to understand, right? Rest of the code remains the same. So find solution, we are starting with 0, 0. So solution matrix, initially we are setting it as all zeros, right? So let's look at this. Initially we are starting with the maze. So I'll quickly run forward. So now we have the maze initialized. Solution matrix is all 0. Input matrix is here, right? 0, 1, 1, 0, 0, 0, 0, 1, 0, right? This is where initially we are. So the first find solution call has been made. You have 0 and 0 as the starting portion. It is first checking, is this the goal? This is not the goal, so it doesn't go there. It is checking if it's a valid portion. It is a valid portion, right? The rat is actually in the top left corner. It's a valid portion. So it is saying that yes, this is part of the solution. So this is the solution matrix. You see the solution matrix here. So it is setting it to 1, the solution matrix, saying that this is a particular portion which it currently thinks that it is going to be part of the end solution. So that's why it's setting it to 1. Now it is recursively calling find solution again with x plus 1. So x plus 1 means currently x is 0, so x will be 1. You will see another find solution instance here. So just remember that it has started here, it is calling this particular code, right? So it has come back to the find solution of 1, 0. This is what we saw in that animation as well. So now we are at 1, 0. Again, we are checking, is that the destination? No, it's not the destination. We are checking it's a valid portion. Yes, it is a valid portion. 1, 0 is a valid portion. So then we are saying that, okay, we assume that this is part of the solution. So you see that solution matrix, both these are 1 now. Now it is checking, okay, hey, first I am going down, right? So again, it's going to call a find solution. So there are 3 instances of find solution, one calling the other, right? So now it is checking, is this the goal? It is not the goal. If it's a valid portion, yes, it is a valid portion. So it is marking it part of the solution, right? So it is saying that this is part of the solution now. Now again, it is calling a find solution of x plus 1, 5. So now it is checking, it is outside the matrix. If you look at it, it is here, right? It has come from here to here to here. Now it has come to 3, 0, right? 3, 0 is not a valid portion because 0, 0, 1, 0, 2, 0, 3, 0. It's checking if it's the destination. It is not the destination. It is checking if it's a valid move. Here actually it is an invalid move because x is greater than or equal to n. Actually x is equal to n. So it will return false here, right? So this particular 3, 0 will now get killed, right? This will be getting killed. Yes, that stack got killed. You see that it is now come back. This is called backtracking. Now it has come back to this particular portion. So currently it is looking at, if you look at it, it has gone down, right? In the find solution, it remembered that it has, so if you look at it, find solution of 49 is this code. It knew that it came out of 49. Now it is at 53. That means it has to look for the right. So where it has to look for the right, it has come from here, it has come from here, it has come here, and now it is looking for a right here. That means the position that we are looking at is find solution of 2, 1, which is nothing but 0, 1, 2, 2, 1. It is in this particular position. Now if you look at it, there is a wall here, right? Is this the goal? No, it is not the goal. Is this a valid position? No, it is not a valid position because the maze of x, y is 1. That means there is a wall here. So it will return false in this particular case. So for 2, 1 also it will get killed, right? So it will come out of 2, 1. Again it is back to 2, 0. This is again the backtracking, right? It is in this particular position now. So it came from here to here to here. It tried to go outside the matrix. It was invalid. It tried to go right. It was invalid. So it has backtracked. It has come to 1, 0. So that's what you will see now. Okay. So it has come to 1, 0. Now if you look at it, very interesting thing in the solution matrix, it is saying that here it has actually cancelled that. Initially it put a 1 here, right? In the 3 by 3 matrix, it had put a 1 here considering that this was part of the solution. Now that it found that, hey, from this particular question, from this place, I cannot go anywhere. So it is now saying this is not part of the solution. So this is the code which is doing it, where you have the solution of x, y equal to 0. That means it is saying that, hey, it is not part of the solution. So in the eventual path from 2, 0, you cannot get to the solution. That's why it cancelled that path. You have to go through this particular area that I'm explaining now 2 or 3 times for you to understand. This is the crux of backtracking. Don't look at the code, copy the code and make sure that it is passing, right? Don't do that. Understand this. This is the fundamental code. This is the only time you need to understand this. After this, for the remaining problems, easily you'll skim through it. For this particular question, listen to this part 2 or 3 times to make sure you thoroughly understand it, right? So 2 comma 0, now it is out. It has come to 1 comma 0, right? So 1 comma 0 is nothing but here, right? 0 comma 0, 1 comma 0. Now it has to go to the right side. How is it doing it? It is actually trying this particular code, x comma y plus 1. So it is 1 comma 0. Now it is going to call 1 comma 1. So it is called 1 comma 1. Is 1 comma 1 a valid position? If you look at it, first, is it the goal? This is checking for the goal. Is this the final destination it has to reach? No, final destination is this one, right? The bottom right is the final destination. So it is saying no. Is this a valid position? If you look at it, 1 comma 0, is this a valid position? Yes, it is a valid position. So it is considering it as part of the solution, right? If you look at the solution matrix, it is updated like this. This is there. 0 comma 0 solution is 1. 1 comma 0 solution is 1. 1 comma 1 solution is there, right? So now it is saying x plus 1 comma y. That means it is going to first try to go down from here. That means it is here, it will try to go down, right? So if you look at, it is here, it will try to go down here, right? First it will try for 2 comma 2, right? So let's try that. What is going to happen? So it is coming to 2 comma 1, which is nothing but 0 comma 0, 1 comma 0. This is the third row, 2 comma 0. Here it is trying 2 comma 1. There is a wall there, right? It is not the goal and it is not a valid position, right? Because there is a wall in this particular position. So it will go back out of this. So if you look at it, 1 comma 1, it will 2 comma 1, it will pop. This will get killed again. So that stack is killed. It is again gone back to 1 comma 1. So now from this one, it has tried down. So from here it cannot go down. So now it will go to the right side. So right side is x comma y plus 1, which is 1 comma 2. So if you look at it from 1 comma 1, it is trying 1 comma 2. So 1 comma 2 is the new stack that has opened. There it is checking for the goal. It is not the goal. Is it a valid move? It is a valid move, right? Because here it is a valid move. It is setting the solution to 1. So in this matrix, currently this is the path. Now this will get added to the path. Yes, this is the path it is adding. Now it is checking from here, can I go to the right or down? So it is going to first always try going down, right? So it is in this current position, it will try to go down here. So it has come to 2 comma 2, right? So this is the last call it has made. It has come to 2 comma 2, which is the destination, right? This is 0 comma 0, this is 1 comma 0, this is 2 comma 0, this is 2 comma 1, this is 2 comma 2. This is the bottom right. Now it is checking, is this the goal? Yes, this is the goal. And so x is equal to n minus 1. So 3 minus 1, 2. Y is equal to n minus 1, 3 minus 1, 2. So x and y both are same. Also you have to check, is the maze in that particular position 0? That means this final position also cannot be a wall. It should be a 0. So it is checking for that. If all these conditions are true, you declare that yes, solution of x comma y is 1. So that you will mark in this particular position also as 1. And then you return true. Whenever you return true, what does it mean? You have found the solution. You don't have to search anymore, right? So I have found one solution, which is enough for me. Now if you look at the solution matrix, it has the path to get to this particular place, right? So that's it. It is not going to search anymore, because once it has found the solution, it is going to return true. So after that, the caller also will return true, caller also will return true. All the stacks are getting killed here one by one, right? So it is getting killed, and finally find solution as a return true. That means it is going to print the solution. Where is the solution? This is the solution, right? So if you print the solution, you will get the solution on the screen like this. So this is the final path we have reached. So this is how backtracking works. This is the crux of backtracking. Now I want all of you to go through this multiple times, at least 3 times. I want you to type this code. I want you to manually do this, whatever I did it on Python Tutor. This is the website where you can see this in animation mode. Make sure you are not using any scanner class or reading input in Python, nothing, because it will not work with external input. You have to initialize the input for this and you have to give it. Then you will be able to visualize it. What is happening inside, you will be able to do a step-by-step analysis. Hope you got how it worked. And again, if you go back to the template that we saw earlier, this is exactly following the template. Just to recap, first you check for the goal. Second, you check if it is a valid position. Third, you assume that that particular position wherever you are is part of the end solution. Then you recursively from that position, you try to move right, you try to move down, right? Both these positions you will try. If you find that there is a path available either by moving right or moving down, you return true. First you will move down. You are seeing that yes, there is a solution available by moving down in that path, means it will return true. Or if you go right and then you are finding a solution, it will return true. In either of these cases, right, you don't see a path from this particular position going down or going right, then you will set solution as false. That means from that particular position, there is no solution available. In our particular case, it happened for this 2, 0. It came all the way to 2, 0, and then there was no solution away from it. Then it marked it as 0, right, in the solution matrix. That's what we are talking about here. Then eventually it will search all the paths and it will get to a final solution. So this is the way backtracking works. Hope you are able to understand this code. Let's discuss. If at all you have a question, you can reach out to me first.